Section 10.4 is on ellipses. An ellipse is the set of all points in a plane such that the sum of the distances from each point to two fixed points is a constant. These two fixed points are called the foci. The singular of that is focus. And just to kind of show you what this looks like, I found this really cool website that has a little animation of it here. So here's your ellipse, and F and G are your foci, and P is a point on the ellipse, and you can see that as you move around, the length of PF plus the length of PG stays the same no matter where you are. Or as they say down below, FP plus PG is a constant, and so that traces out an ellipse. Actually kind of cool. Okay, so an ellipse can either be horizontal, that is longer in the x direction as the x-axis goes, or it can be vertical, longer in the y direction as the y-axis goes. The major axis is a segment that contains the foci and the center. Its endpoints are called the vertices, and that's the longer distance. The minor axis is a segment perpendicular to the major axis that goes through the center, and its endpoints are called the covertices. So here's a diagram from your textbook. So here we have a horizontal ellipse, okay, and the major axis is here in blue, since that's the longer one. The minor axis is perpendicular to it in green. We have the center, we have the foci. The two foci are on the major axis, our vertices, and then our covertices. Same thing for a vertical ellipse, except this one is more up and down, so my major axis is actually vertical, my minor axis is perpendicular to it horizontal, and remember the foci are going to be on that major axis. So in this section we're going to take a look at ellipses, only those that are centered at the origin. So for a horizontal ellipse, one that is longer on the x-axis, the standard equation is x squared over a squared plus y squared over b squared is equal to 1. And for all of these ellipses, a is always greater than b, which has to be greater than 0, because you can't have 0 in the denominator. Okay. Now if it's a vertical ellipse, the equation is slightly different. It's x squared over b squared instead of a squared plus y squared over a squared is equal to 1. And again, a is greater than b, which is greater than 0. Here's how I remember it. A always has to be the bigger number. If the bigger number is under x, the x squared, then it's going to be in line with the x-axis. It's going to be longer from left to right. A is your bigger number. If a is under y, then it's going to be longer on the y-axis. It's going to be stretched top and bottom. That's how I remember it. Let's take a look at a couple examples here. First one says, write the equation in standard form of an ellipse that is centered at the origin, that has a vertex at 8, 0 and a covertex at 0, 5. For me, the easiest way to do this is to do a little sketch. So I have one vertex out here at 8, 0, and then I have a covertex up here at 0, 5. So if it's centered at the origin, that means my other vertex has to be out here at -8, and my other covertex needs to be down here at -5, and it's going to look something like this. I have a hard time drawing ellipses. They tend to look more like eyes. Okay, so what that means is that this tells me what my A and B are. My A is this distance right here from the center to a vertex. So my A is equal to 8. B is the distance from a covertex to the center. That would be this right here. So my B is going to be equal to 5. This one is longer in the x direction, so my formula is going to be x squared over a squared plus y squared over b squared equals 1. So substituting in those values, I'm going to have x squared over a squared is 64 plus y squared over b squared, b is 5, so over 25 equals 1. I find that doing a little sketch really helps out a lot. So to find the coordinates of the foci, we can use the Pythagorean theorem. So here's a sketch from your textbook. So if A is half of the length of the major axis, and B is half of the length of the minor axis, and then C is the distance from the center to a focus, then we have basically a right triangle here where you see that b squared plus c squared is equal to a squared, or rewriting it, I kind of like this one better, c squared is equal to a squared minus b squared. So let's use that to find the foci of an ellipse whose equation is 4x squared plus 36y squared equals 144, and then we need to graph the ellipse. You'll notice that this equation is not in standard form, so I need to rewrite it that way. You'll also notice that the equation of every ellipse actually ends up being equal to 1. So to make this equal to 1, I'm going to divide everything by 144. Then that's going to give me x squared over 36 plus y squared over 4 is equal to 1. So this value right here is going to be a squared. So a is equal to 6. This value right here is going to be b squared. So b is equal to 2. How did I know that? Remember, a always has to be bigger. And if a is bigger, this is going to be a horizontal. Whoops. Horizontal, so longer in the x-axis direction. Okay, and I need to find the foci, so I'm going to use c squared equals a squared minus b squared, or c squared is equal to 36 minus 4, or c is equal to the square root of 32, which I'm going to simplify to 4 square root of 2. Let's go ahead and graph this. So I know I'm centered at the origin. A is 6, so I'm going to go out 6 this direction, and 6 this direction. And b is 4, so up and down 4. Graph that, connect those points, try to make it look as oval as possible. Now my foci are going to be on this major axis here, so that means those are going to be the x-coordinates. So I will go 4 square root of 2 units this way, and 4 square root of 2 units this way, so that's going to be positive or negative 4 square root of 2, comma 0. And those are my foci. This one says write an equation in standard form of the ellipse that has foci at 0, comma plus or minus square root of 17, and covertices at plus or minus 6, comma 0. Again, I'm going to do a little sketch. So I have a covertex here, I'll label that CV, and I have a covertex here, and then my foci are going to be up here at square root of 17, and down here at negative square root of 17. Okay, so that means that this here is going to be that the y-axis is going to be my major axis. So this one is actually, this ellipse is going to be vertical. So C is equal to the square root of 17. Since this is a covertex, that means that my B, this distance right here, is going to be B. This distance is C. B is 6. So, and I don't know what A is. That's what I need to find. So C squared equals A squared minus B squared, or 17 equals A squared minus 36, or A is equal to the square root of 53. So I know that this is going to be a vertical ellipse, so it's going to be in the form x squared over b squared plus y squared over a squared. Remember, a squared, a is always going to be bigger, and if it's vertical, the bigger number is going to be under y, is equal to 1. So x squared over 36 plus y squared over 53 is equal to 1. And there's my equation for that ellipse. And our last example asks us to write the equation of the ellipse that is graphed below. And so again, it is centered at the origin, which is kind of nice. And you'll notice that the foci are on the y-axis, so that means that this one is also going to be a vertical and will be of the form x squared over b squared plus y squared over a squared equals 1. And I need to find my a and my b. Well, from here, from this point here down to the center, where's my, oops, I think I went a little low on the center there, to the center, that distance is 5. So my a is going to be 5. I don't know what my b is. I don't know what this distance here is, and I can't guess because that's not an exact point. And I know that the distance from my center to the foci is c, so I know that my c is 2. So I will use c squared equals a squared minus b squared, or 4 is equal to 25 minus b squared, or b is equal to the square root of 21. So plugging those into my formula, I'll have x squared over 21 plus y squared over 25 equals 1. So in this section we took a look at ellipses, horizontal and vertical, and focused primarily on those, solely on those that are centered at the origin.